In this video, you will learn how to identify the critical parts and how to graph a horizontal ellipse. So, looking at our picture of the ellipse below, you can see a long blue line going horizontally. That's our major axis. The way that you tell if an ellipse is horizontal or vertical is by the major axis. If the longer axis, the major axis, is horizontal, it's a horizontal ellipse. Now, at the end of the major axis, you notice two blue dots. These are called vertices. The vertices are going to be the endpoints of the major axis, which again is the longest axis. Next, let's look at the shorter green axis. The shorter axis is called the minor axis. The endpoints of the minor axis are called co-vertices. Now the two axes intersect at your center point. Similar to the parabola's vertex, the center comes from HK. You will also notice two purple dots on the major axis. These are called your foci. Foci is really just plural for focus. If you notice, similar to the parabola, it's inside the curve of each end of the ellipse. Let's look at now how we're going to find where those foci should be positioned on your ellipse. I would ask you to look at the ellipse here. You can see that B is represented by the length from the center to the co-vertice, so half of the minor axis. C is the length from the center to the focus. And A, that's the length from the center to a vertice, half of the major axis. But it happens that that's also going to be the length of the hypotenuse of the right triangle that we create when you connect the co-vertice and the focus. Now, if you recall your Pythagorean theorem said that b squared plus our c squared would equal a squared, the hypotenuse squared. If I wanted to be able to solve for c, that would just require me to subtract the b squared. I then would have our c squared equal to the a squared minus the b squared. Lastly, to get rid of the square, I can square root each side. That's going to give me a final equation of c equals the square root of our a squared plus b squared. Oh, sorry, I meant a squared minus b squared. So let's now go to the next page to do some of our definitions. So again, similar to the parabola and actually your circle, you'll notice the x minus h quantity squared and y minus k quantity squared. Again, the h is going to be the x value of your center, and k will be the y value of your center, because h is with x and k is with y. Also, you're going to notice that it will be the opposite of whatever the value is there, because these are both inside parentheses. Now, another thing is we need to be able to know how to tell that the major axis is horizontal based on our equation. For that, I'm going to look at this a squared value. Basically, if a squared, which will be the larger number, is under the x term, it's going to be horizontal. So let's now talk more about that a squared. The vertices come from taking the square root of a squared. And so if you wanted to know where the vertices were, you could take your center point and go from your center along the x direction, so horizontally, plus and minus our value of a. So basically, if you're thinking about the graph, you're going to move a units the direction of the major axis. Similar, the covertices come from taking the square root of b squared. So if I start at my center and move b units the other direction, so vertical, I'm going to take h and then k and add and subtract b. So again, thinking about the graph, I basically want to go b units the other direction. Now, we already have our formula for figuring out c. c is going to be the square root of our a squared minus the b squared. Once you figure out that value, you can use it to find your foci. Again, you want to start at your center, and then because we're looking horizontal, I want to move horizontally plus and minus c units. So again, I'm going to move c units the direction of the major axis. Now that we have everything defined, let's go ahead and look at some examples. Again, this is not defined the way that we did, so I would go ahead and write it with our h and our k. First of all, because I see the larger denominator of 25 under x, I know this is going to be a horizontal ellipse. I also see that we are subtracting 0 from both x and y. So my center is 0, 0. And just like the parabola, I'm going to want to go ahead and plot that as soon as I know it. Next, we again need to take the square root of 25 to get an a value of 5. And so what that means, since again we're horizontal, is I want to move from my center horizontally, left and right, 5 units. Then I just named these in my chart. Next, I want to look at the covertices. Here, I'm going to take the square root of 9, the smaller denominator, which gives me a value of 3. I want to move the other direction then 3 units. So up and down, vertically. Next, we need to find our foci. But before I do that, I would recommend drawing your ellipse shape on your graph. This makes sure that you will only connect vertices and covertices, since that's pretty much the only thing we have drawn at this point. So now, after I do that, I need to find the value of c to find my foci. So c is going to be the square root of our a squared minus b squared. So here, that's the square root of 25 minus 9, which is the square root of 16, and simplified down to 4. So what I need to do is go from my center 4 units the direction of the major axis, which here is going to be horizontal, left and right. And then again, I just name those ordered pairs in my chart. Please now pause the video and complete example B. Please now check your answer for example B. Again, you'll notice the 36, the larger denominator, was under x. That's how I knew it was horizontal. My center was 0, 0. And then, because the square root of 36 is 6, from 0, I had to add and subtract 6. Go left and right 6 to get my vertices. Similar for the co-vertices, the square root of 16 is 4, so I went the other direction, up and down 4. Now when I figured out C, I didn't get an exact value, but that's okay. I can still simplify the radical, and then I want to use that simplified radical in my chart. In your chart should always be exact answers, never rounded. So when I was writing the foci for the chart, again I started at 0, and because going left and right changes the x values of the point, I added and subtracted 2 root 5 to my x value. Now you're welcome to write your answer as I have, or you can write them as 2 separate ones. You'll notice though, in order to plot those values on my graph, I needed to get a decimal approximation for 2 root 5. That told me that I should be going left and right about 4.5. At this point, please compare yours to your partner's and then complete the examples on the next page.